9702 October November 2021, paper 1, variant 3, question number 9. So again, it's a question of from the general physics, dynamics is a part, and especially it is covered by the graph. Skydiver leaves a stationary balloon and falls vertically through a long distance. So from this, we understood that the skydiver initial velocity is zero, and through a long distance means air resistance is there. Which graph best represents the variation of the acceleration of the skydiver with the distance s traveled as she falls through the air? So we see that whenever a person jump from stationary position, uh, leaves the balloon, right? Its acceleration is exactly equals to the acceleration due to gravity. But when the air resisting force appear to be applied, so it will gradually decreases with the frictional force, and the acceleration was at that time will be frictional force over m. So the acceleration due to gravity will be decreases with frictional force divided by mass. So until the acceleration becomes zero. Until the acceleration becomes zero, that means at that time terminal velocity arrives. So this point made a confusion in some students in the year 2021 on this paper. They thought that this is a case of terminal velocity, and they marked B. They marked B. Considering the fact that air is acceleration is gradually decreasing with the zero. So this is not the actual case. Actual case is firstly the acceleration is equal to the acceleration due to gravity. Then the frictional force appear. So frictional force over m beats the acceleration for frictional force. So it will be decreased right until the acceleration becomes zero. So if we see the d, which is constantly increasing, which is after the time distance, after the distance, so it is incorrect. Acceleration constant throughout the distance, it is also incorrect. Acceleration becomes a constant value, it is not zero, right? It is a constant value, right? It is actually also incorrect, it is become zero. So this graph is the best representation. Why? Because at certain distance, attaining certain distance, the acceleration becomes zero. So option A is the right answer.